to you as we go along, or should we wait to the end?
We have got time at the end for questions, so if you could wait to the end, that would be fantastic.
Fantastic. We shall do that. We are in your capable hands. Thank you very much.
Great. Thank you so much. We do have a presentation to share, so hopefully we won't have any issues with getting that loaded in.
We have no issues. We've never had any issues at all. So.
Can you just confirm that you can see that okay for us?
Yes, that's absolutely perfect. Fantastic. Look at that. Great.
Fabulous. Thank you so much. So we are going to be giving an introduction to a really exciting project that we're delivering within the local area. As you mentioned earlier, it does have a focus on carbon capture and storage. So during the session today, we're going to be giving a brief introduction to who we are. We're going to be given a brief introduction to the project that we're delivering locally. We're going to have a bit of a conversation around careers within the industry and how young people within the local area can support the energy transition and that drive towards net zero. And then we're going to have some time for questions and answers at the end. We'd be more than happy to answer any questions that you might have. So who are we? We are a number of different companies that are involved in delivering the same project. So my name's Laura, I work for Technip Energies, and Technip Energies are part of a consortium with GE Vernova. Now, as part of the consortium, we have individual aspects of the project that we are responsible for, but Technip Energies are responsible for the overall project integration and the carbon capture element. GE Vernova are responsible for the power equipment manufacture, and then we are also supported by our construction partner, Balfour Beatty. So I am very conscious that not a lot of people will have heard of Technip Energies. So a brief overview of who we are as an organisation. We're a leading engineering and technology company for the energy transition. So what that means is basically our focus is on developing solutions to create cleaner and greener energy. The business has been operational for over 65 years, and we've currently got over 500 projects under execution. We use over 60 leading technologies within our projects, and our 17,000 employees, which are spread across 34 countries across the globe, are really committed to delivering, the best possible projects for our clients. So we're a financially secure organisation, and I've got just a brief video to play, which gives you a bit of an insight into who Technip Energies are and what it would be like to work for us. So I'm going to hand over to Tracy from Balfour Beatty to give you a little bit of an insight into who Balfour Beatty are and what they do.
Hello everyone. I'm not sure how interactive and engaged we've been this morning, so I'm not sure if you can give me a reaction. How many of you have heard of Balfour Beatty? Can you give me an emoji, a thumbs up if you have, or a smiley face?
have a look in the chat box. I'm going to see if we can get some emojis up. There we go. Miss Elliott has.
Excellent,
We
Miss
have.
Elliott. Great stuff. Okay, so Balfour Beatty have been around for 116 years. Clearly, myself and Julie haven't worked there that long, but yeah, we've been around building things, and we have an expertise in this area. We've currently got 14,000 people working in the UK. But we've also got people working in the US and in Hong Kong as well. So we've got 27,000 employees in total, or thereabouts. And what we do is essentially we build things. So we build roads, we build schools, we build hospitals. We built the aquatic centre at the Olympic Stadium. We've built the Disney Princess's Castle in Florida. And in 1991, we completed work on a mission control center where astronauts working on the International Space Station are coordinated from. I would encourage you to do your homework after this session and have a look at Balfour Beatty and have a look what we're about, to understand a little bit more about what we do build and about what we do develop and maintain. And we've got a little video too to bring to life some of our projects. That's just a snapshot of some of the things that we do build. And we're now going to have a look at the important project that we're working on collaboratively in Teesside.
So what is the Net Zero Teesside power project? I would be keen to understand if anyone's heard about the project, but I recognise that it's very, very difficult for you to confirm whether you've heard about it. But if you have and you've got time to pop in the chat that you've heard about the project, that would be great. If not, we're going to give you a brief oversight and overview. So Net Zero Teesside Power is a really important project for the Teesside area. It's poised to be the world's first gas-powered fire station with carbon capture technology, and it will capture up to 2 million tonnes of carbon each year. The power plant will be capable of generating over 740 megawatts of flexible, dispatchable, low-carbon power, which will be sent to the UK power grid, and that's the equivalent to the annual electricity requirements of over 1 million UK homes. So it's going to be a real positive for the local area. Now, the Net Zero Teesside Power project is being built in parallel with Northern Endurance Partnership by 9 contractors. So there are 9 different organisations that are involved in the delivery of these projects, and the projects have a combined value of around about £4 billion. The project is poised to create and support 3,000 plus jobs during construction and a further 1,000 jobs during operations. So we do have a bit of a sneak peek at what the power station will look like to show you. So this is what the power station will look like once it is constructed. And we're going to just play another video which gives you an insight into how the power station will generate electricity and capture the carbon from the atmosphere as well. So hopefully that video has been very insightful for you to give you an oversight of the project. And I think you can see from the video and also the picture that we showed the sheer size and scale of this project that's being delivered in Teesside.
Pretty impressive stuff. The project will span across the region of about 72 football pitches. So if you're into your football, then that might give you an idea of, you know, the size of this project. So today we're talking about net zero. And why does net zero Teesside matter? Well, it's critical for a sustainable future. And sustainable is one of Balfour Beatty's 5 core values, and it really is integral to how we're building new futures to Balfour Beatty's, our industry, the communities, and the environment in which we work, and for our stakeholders as well. Most critical to Balfour Beatty's business success is our sustainability strategy, and it focuses on 6 key areas, as you can see here on the slide. So we've got climate change, we've got nature positive, we've got resource efficiency, our supply chain integrity, community engagement, which we're doing now today with you guys, and our employee diversity, equity and inclusion. And those 3 pillars are all around leaving a positive social legacy. we recognise the scale of the challenge in a carbon intense industry with its dependence on the heavy plant and machinery and concrete and steel. And our net zero targets are really ambitious, but they are attainable. And they've been underpinned by some industry leading carbon reduction plan and validated by science-based targets as well. And the carbon reduction plan gives full transparency of our pathway to net zero. What we're going to do is we're going to have a look at some of the different career paths with regards to the roles that we need on this project.
So the first couple of slides that we're going to show you in this section, we hoped to make a little bit interactive for you. So we're going to play a little bit of a game that you might be familiar with. And I was hoping that the slides would work, and now I've lost my, there we go. Oh, we're back. So, how many different jobs are there within engineering and construction? We are going to give you some answers. We would love for you to type in your responses in the chat, in the meeting chat. We're going to give you a couple of seconds to discuss amongst yourselves and then get the answers in there before we reveal the correct answer. So, do you think it's A, 25, B, 75, C, 100, or D, more than 150? And unfortunately, we can't call a friend on this one. So we've got a couple of answers coming through there. We can also see the questions that you're popping in the chat, and we'll come back to those later on in the session. So that animation's a bit off. So that was the countdown. But if you said 25, you would have been incorrect. I keep losing them. Sorry, I do keep losing the mouse. We're working on dual screens at the moment. There we go, we're back. If you said B, you would have been incorrect. If you said C, oh, sorry, you would have been incorrect. The answer was, of course, more than 150 different jobs. So the second question we've got is, how many more workers are needed within construction by 2030? Do you think it's A, 30,000, B, 35,000, C, 40,000, or D, 45,000? So again, we're going to just give you a couple of seconds to put your answer in the chat. Okay, we can see we've got a few correct answers there. If you said 30,000 or 35,000, that would be correct. If you said 40,000, so if you answered C, that would have been correct. So we do have a question for you now. We can see that there's a number of different jobs available within the industry, and I'll hand back over to Tracy and Julie to go through some of those jobs with you.
So from the list of jobs that you can see on that slide, which ones do you think are needed in engineering and construction, and which ones aren't needed? So have a quick look at that and have a little bit of a discussion within your groups. And if you can put your answers in the chat, that will be very helpful. So which jobs are needed and which jobs aren't needed?
So we'll just give you a few seconds to have a conversation between the classes and get some answers uploaded into the chat. We'll watch for those coming through. We are very conscious of time frames, so if you can put answers in the chat as soon as possible, that would be great.
Hey, we're not seeing anything come in the chat. Not quite sure if we've got a delay or if you're still thinking about it. Great, Mrs. Whitfield. All
There we
of them.
go. Okay, brilliant.
Yeah. So yes, you're absolutely correct. Everybody who's responded in the chat are correct. All of them. We need everyone from drones pilots to IT specialists. You know, it's not just about engineering or bricklayers, which are obviously obvious ones, but social impact and environmental specialists. We do need all these roles in the construction industry. We have administrators throughout our offices, obviously accountants, which are quantity surveyors within our departments. So yeah, we do need all these people. Digital 3D model makers, they're the ones who make a plan, like you saw, of net zero and animate what the project's actually going to turn out like. So there are so many different jobs within our industry and construction that you could get into.
So what we're going to do is now we're going to have a look at play a bit of a game of guess who. So on the slide here, you can see some of the skills required. So who am I and what skills do I need? So this person on site solves complex problems. They design systems and structures. They apply scientific principles, STEM, and they ensure safety and efficiency. And they work in specialised fields like chemical or electrical. So who do you think that role is within the construction industry? Wow, I've got an answer already. Any advances on engineer? Well done, Mr. Mann. Sorry.
Yeah, so we've also outlined some of the key skills that would be required by engineers. There are various engineering pathways that that students could think about. So, you know, it's really key that they investigate the options and opportunities that are available within engineering if that's an area of interest.
So who am I and what skills do I need for this particular role? I work with 3D software. I help visualize projects before they are built. I create detailed digital models. I collaborate with architects and engineers. I make virtual designs come to life. I think I give you a little bit of a hint as well earlier on, so maybe but please do put your answers in the chat.
Okay, so
Thank you, Mrs. Whitfield, for your response. Thank you, Miss Elliott. Thank you, Dallas. So the key skill, it was a digital 3D model maker. Well done for everybody who responded back. The key skills required for this particular role is, you know, you have got attention to detail and you are very creative in being very creative. Also that you enjoy technical skills and learning them, and also you enjoy collaborative working. Very much part of a working team with this role. as well as working individually as well. So well done, everybody.
Okay, I think we might have time for one more. So who am I and what skills do I need? So in this role, I care about the communities I work in. I study project impacts on people. I promote positive social outcomes, and I engage with stakeholders, and I help projects be socially responsible. Who do you think that role could be? Wow.
So we can see that the answers are coming through currently. So we've got answer from Miss Elliott, Miss Goodall, Dallas. Okay. So actually a social impact specialist, and key skills required for a social impact specialist role include empathy. We work a lot with people from disadvantaged and vulnerable backgrounds, so it's really important that we understand, you know, their situations and the impact that our work can have on them. We liaise with lots of different key stakeholders as well, so communication is definitely one of our strong skills, and analytical thinking as well. We work in various different communities, and one of the areas that our role focuses on is addressing some of the societal needs. So we have to think very analytically around how we can support communities whilst we're working in the local area. So we hope that's given you a bit of an insight into some of the careers within the industry. Do you have any questions for us? Now, we can see that there have been a few that have already been put in the chat. We have been able to respond to one of them, which was around what happens with the carbon and how is it captured, where is it stored. So the carbon that is captured by the power plant will actually be transported by a pipeline out into the North Sea, where it will be buried deep underground. We've had another question come in around, let me just have a look for the questions. Can you remember what
just go up. What if the CO2 gets?
So another question that came in was, what if the CO2 gets out? So the CO2 is pumped underneath the ground at the bottom of the sea, and it filters into lots of little cracks at the bottom of the ocean, and it's then sealed, so there's no chance for the CO2 to escape. We've had another question asking about what qualifications they should aim for if they want a job with any of the companies, and how many apprenticeships are available. I am going to say that within both organisations, and Tracy, Julie, let me know if you have any other views, but I am going to say that certainly within both organisations, strong mathematical skills are required. Certainly within Technip Energies, you know, dependent on the job role, science is, you know, very highly sought after. You know, dependent on the job role, the qualifications can vary. In terms of apprenticeships, Balfour Beatty have taken on a cohort of apprenticeships this year. As it stands at the moment, we don't have numbers for a potential intake in 2026, but once you know, we have made a decision around whether we can support opportunities in 2026, then any roles will be advertised locally for students to apply for.
One top tip I would like to share with you is that, yes, it's important that you have you know, you've got some qualifications. However, we also employ for attitudes and behaviours. So if you come into our business, you're curious, you're excited, you're enthusiastic, and you want to learn, then you know, there's a job.
That's good to know. One of the jobs that I noticed in your job list, which I thought was fascinating, was archaeologist. And it's one of those jobs that people just wouldn't associate generally with companies like Balfour Beatty involved in big construction. And I'm just wondering if you could briefly talk about that.
Please. We have a project at the moment where we're constructing something, and unfortunately when we've dug into the ground, we've found what seems to be Roman remains of a building, and so archaeologists, we have to stop what we're doing and have our archaeologists come along and see, you know, if it's something that we can't work around, or how we go about it then. And obviously the important find, it might be artifacts that they find, which will then be taken to a museum to be verified. So yeah, we do definitely employ archaeologists within our work.
It's really important. I remember Balfour Beatty, when Crossrail was being built in London, they had a beautiful exhibition of some of the incredible stuff that was found underneath London. It was amazing, and it's one of those jobs that it kind of gets forgotten, but it's a really important job. So thank you for mentioning that. This is one more question as well, and it's a really good question. Why gas? Why? It's from Kath Kershaw. She wants to know why is it a gas power plant?
I think in terms of the gas-fired power plant, we are not currently in a position where we can fully move away from fossil fuel use. So we are still developing technologies to generate cleaner and greener electricity. But in terms of meeting the energy demands within the UK, we are still very heavily reliant on fossil fuels.
It's a very good point. It's this idea, and one of you mentioned it actually, this idea of transition, and it's so important. It's impossible just to turn the tap off completely. We have to sort of transition to new ways of powering our planet. But things like carbon capture and storage is such a good way of helping that transition. And while we do still use fossil fuels, of making them as clean as possible. So it's such an amazing project, and also the fact that it's happening in the northeast. The north of England was responsible for the Industrial Revolution, and it's now kind of taking a pride of place as we hurtle into a much greener future. So it's really good to see.
Yeah, it's definitely a very exciting project, not just for the northeast, but the whole of the UK. There is, as we mentioned earlier, this is poised to be the first in the world of its kind that is being delivered locally. So there is a lot of interest, not just across the broader UK, but across the world on this project as well.
Any more questions? We've got a few more minutes left, so I'll let you crack on. I just wanted to jump in with a few more questions if I see them.
Have we said where it's going to be built?
No, we haven't.
Yeah. It's actually, well, are you people on the call, are you familiar with Redcar? Yes. You've had a lemon top there, or some fish and chips, or walked along the beach.
Any Redcar? Do we have anyone from Redcar? Yes, we're all familiar with Redcar.
Fantastic. Well, that's where this first in the world carbon capture power station is going to be built, and it's going to put us back on the map.
Fantastic. That's great. Not that Redcar needs to be back on the map, because it's always been on the map.
Highlighted.
There's another, it was funny actually, I was thinking about carbon capture and storage, and I was in Iceland a little while ago, and they had a similar rather experimental way of carbon capture of storage. And there was a question about what do we do with the carbon dioxide, and what they did with their carbon dioxide that they collected was actually pump it deep underground. And because Iceland is so geologically active, that carbon dioxide would just, under pressure and under heat, would just chemically turn to limestone. So rather than it remaining as a gas in porous rock, it actually physically turned into stone. And so it could just be ground up and used and would never enter the atmosphere. There's all these incredibly creative ways of dealing with waste carbon dioxide, which I'm always amazed about.
Yeah, there are numerous ways that carbon dioxide can be used, and what you've just mentioned there is very similar to the process that we are using within the power plant with the carbon capture unit, in terms of cleaning the carbon gas and changing it from kind of a gas into a liquid/solid, where it's then transported out into the sea. As we mentioned, it will be pumped into kind of the crevices under the sea, and ultimately it will turn into stone, as you mentioned. But there are other ways that carbon can be used. So it can be used for creating building materials, for example. So you can see we've just had a question in the chat. What subjects are really important for my students to focus on if they want to work as an engineer? So engineering is a really broad field, and there are different engineers who will be required to undertake different subjects dependent on their area of specialism. But engineering, certainly, like I said, maths, science, or chemistry, physics, would be really, really helpful depending on the field of engineering that students would like to go into. Got anything to add?
No, I think that's...
Do we have any other questions?
Just a couple more questions into how. Oh, that's well, AI is the perennial question, isn't it? How is Balfour, Beatty, and other companies going to be, big engineering companies going to be using AI? It's a good question.
We've made a big investment in AI, and we're currently we've piloted Copilot. So we've been encouraged to use that in whatever ways, shapes or form that we can. So we're just at the start of a journey, so to speak, with regards to AI. But we've made a massive investment in Balfour Beatty in AI. I'm not sure about in what space Technip are in.
Yeah, Technip are along the same lines as Balfour Beatty, Tracy, in terms of that investment. You know, we have access to AI tools. We are actively being encouraged to develop our knowledge and awareness of AI and how to use AI. From my perspective, I find AI very, very useful for drafting things like case studies, for example, that ultimately can be quite time consuming once we've delivered initiatives within community settings. But using AI to draft those case studies can reduce the amount of time that it takes to develop those. You know, in terms of moving forward, AI could be potentially used to develop the 3D models that some of our digital teams work on. So there's multiple different uses for AI within the industry.
We won't have even thought of them yet.
No, we won't. It's still very new.
Yeah, well, that's the people who are watching this program. That's their job, is to come up with the brilliant ways of thinking about AI. I mean, I think about perhaps using AI as well, coming up with solutions for things. It's like, okay, well, this is how we're building a power plant now. How else could we do it? How could we make it more efficient? How could we make it cleaner? And see AI as a design tool. Who knows?
Yeah. And we've got another question. I don't know if we've got time for this one.
Very quickly. I think so. You've got all your companies, you know, Technip down there, and I see carbon capture by Shell, all these different companies working with you. Maybe you could take us through some of those.
So we rely heavily on supply chain partners for delivery of projects such as this. You know, we all have different areas of expertise. So for Technip Energies, that is the carbon capture element. For Balfour Beatty, their area of expertise is construction. But Balfour Beatty may also require help from subcontract partners to deliver work on the project as well. So there will be multiple companies that are involved in the delivery of this project. And it could be anything from, you know, transportation and logistics. It could be scaffolding, hospitality. It could be electrical installation, engineering, so consultancy services. So, you know, the supply chain for a project such as this is significant.
Fantastic. Well, listen, thank you so much. That was an absolutely fascinating presentation, and I very much enjoyed your Who Wants to Be a Millionaire quiz. It was a triumph, I thought, of of a quiz. It was terrific, and it's such an interesting project. And if people want to find out a little bit more about it, presumably they can Google it and find out more that way.
Yeah, there is a dedicated website for Net Zero Teesside Power, so people can access details of the project that way.
Well, listen, Laura, Tracy, Julie, what an absolute pleasure. Thank you very much indeed for bringing that to our attention and for taking us through it. And it was a really entertaining and fascinating talk. So thank you very much indeed. Thank you. Right, we are going to move on now. We have got Leonie Briggs, I think, is going to be our next speaker. Leonie Briggs is a science teacher and a STEM leader, and she has her Amazelab talk that she's going to give. And I think this is a really interesting one. She's going to be taking us looking at the life cycle of glass. That's something that we don't think about every day. We're going to go inside a glass factory, I think. So is Leonie there?
I am. I'm here.
Hey.
Nice to see everybody.
How are you? I can't see you. Where are you?
Oh, I should be there somewhere. I am here. I promise.
But I can't see. Oh, there you are. Hey, nice to see you. Glass. My goodness, what an amazing stuff glass is. It's one of those kind of miracles of a material that I don't think we pay enough attention to. So I'm really, really interested to hear what you have to say about it. So I'm going to hand it over to you. And as ever, teachers and classes who are watching this, if you've got questions that spring to mind as Leonie is speaking, whack them in the chat box, and I'm sure she'll be happy to answer them. So away you go.
Oh, thank you so much. Hi, everybody. It's absolutely amazing to see you all this afternoon. So thank you for the introduction. Yep, I am Leonie from Amazelab. I'd just like to say as well, the absolute celebration of girl power as part of this STEM event today. Wow, absolutely amazing. And also the representation from the north. Especially from South Yorkshire. So well done, everybody. Absolutely amazing in the presenters. Super proud of that. Also being a female in the STEM industry, and I'm currently based in Barnsley in South Yorkshire. So absolutely brilliant to see. Well done, everybody. So over about the next 45 minutes, I am hoping that you're all going to join me on an absolute mission, because I need all of you to become glass explorers. So there are some little tasks that you are going to have to do, and the STEM team, when I say, should have lined up a video for us, because if not, I think it might be quite hard for you to understand the journey of glass. So I will check, and hopefully, like I say, the STEM team should have lined up that video ready for us. So we'll have to see. Hopefully they will give me a signal when they are ready with that. So your challenge this afternoon, thank you guys, I'll let you know when we're ready. Your challenge this afternoon is to become glass explorers. This isn't just a challenge for the next 45 minutes. Oh no, I need everybody out there to lead a whole school initiative. So I want it to be that this challenge is long lasting, that we start a whole movement in school, because you are going to launch a brand new school initiative focused on glass recycling. What's going to happen is you are going to form teams. So hopefully in your classrooms, and hopefully this isn't going to cause too much chaos with your teachers, ideally if you could work in teams of about 5 or 6, all you're going to need is some pens and some paper. So I'm just going to give you a couple of minutes to see if you can all organise yourselves in teams. Like I say, I'm hoping it's not going to cause too much chaos, but over the next 2 minutes, if we could start to just go into teams of approximately 5 or 6, and then if we can just grab just some A4 papers, absolutely fine, and ideally some colouring pens. So 2 minutes, off you go, guys. You can give yourselves a team name, and you do need a team captain. So please just be organising yourselves over the next 2 minutes into teams of approximately 5 or 6, and then make sure you have got some paper and some pens. As you're organising yourselves, can we please have a team captain, and you can have a team name. Now, ideally, I would like that team name to be based on glass recycling, but you might be struggling at the moment to think, well, what's my team name based on glass recycling? But hopefully soon, once we've shown you the video, you will know. So guys, just another 30 seconds, get ourselves into our teams, start across the classroom in our teams. Hopefully we've all got a team captain. You've started thinking of a team name. Right, brilliant, fab. Because like I say, the whole purpose of today is we are all going to become glass explorers, and we're going to launch a whole school initiative ready from 2:30. Like I say, this isn't just 45 minutes, this is a whole lifetime of adventure. I'm loving some of these team names. Yes, guys, brilliant. Right, so what we've done is we have prepared a video. It only lasts for about 6 minutes because unfortunately it would have been quite hard for you all to go on a quick tour of a glass factory. They are based around the entire country. We work closely with the team in South Yorkshire. In fact, we've written this workshop today with a fantastic team at British Glass and Glass Technology Services. And I will let you into a bit of a secret. It's really, really important that we're listening, that we're taking notes, and we're ready to be glass explorers, because the team at British Glass have offered up a prize. Oh yes, soon we are all going to design posters for our glass recycling initiative. And if you take pictures of those posters, obviously with adults' permission shared by your teacher, you need to submit your entries to glassexplorers@britglass.co.uk. I'll make sure that goes into the chat for you. And the winning team will receive a £50 Amazon voucher. So make sure that we are watching and listening really, really carefully. So team, we are now going to play you a video. It lasts for approximately 6 minutes, and it's going to take you on a full tour of how glass is recycled and why it is so, so important. So thank you, team at STEM Learning. If we could please have that video, that would be absolutely amazing. Thank you so, so much.
From what they're made of and what happens to them when you finish with them. Well, let me and British Glass show you. Glass has been around for thousands of years, dating back to the Stone Ages, and the recipe hasn't changed that much in that amount of time, although the production has. Today, the UK produces over 8 billion glass containers. That's the equivalent of 119 bottles or jars for each person, and we're going to find out how it's made and how important it is to recycle it. I'm here today at NSERC, home of the largest container glass furnace in the world, to see what goes into making one of these. This factory makes more than 2 billion glass containers a year and is the only glass plant in the world with its own filling station. We're going to find out the benefits of glass, why recycling is so important, and how they're reducing their carbon footprint. Hi John, so can you tell us a little bit about what you do here at NSERC?
Yeah, sure. I'm the plant director for Elton Glass. I've been here for 3.5 years and I look after the glass operations.
Amazing. So it's a fabulous facility. Can you tell us a little bit about the process that you do in this section?
Yeah, sure. Well, this is the nerve centre of the glass plant, to be honest. This is the battery furnace control room. So this is where we control the furnace technology and also the recipe that is incoming into the batch that feeds the furnaces that melts to make the glass. So a real critical part of the operation. You can see here we've got the bank of screens controlling all our condition monitoring of the glass temperature itself, also water temperatures around the site, water levels around the site. Everything that we need to make glass safely and effectively is controlled from in here. You can see the cameras on the screens there that are showing the actual inside of the furnace. We've got amazing cameras that can withstand the heat in there, and that shows the glass moving forward and the batch slowly melting as we go through.
In terms of recycling then, a facility like this, how much recycled material do you actually use?
It's a good question because it's really, really important for us. So on the one hand, from a sustainability and environmental point of view, it's critical for us to increase our recycled glass content, but actually it reduces the energy we require to melt the glass to reform it, so it's beneficial to us as well. However, we are restricted to the amount we can get from a supply point of view, sometimes from a quality point of view. So at the moment, for example, on our amber furnace, we're putting around 60% recycled glass into the recipe. And on our flint, our clear glass, we're injecting 37% recycled glass. So an average of probably around about 45% recycled glass as a whole.
Fantastic. To find out where NSERC gets some of its recycled glass from to use in their furnace, we're heading to Beats and Clark. Here at Beatson, they process 42,000 tonnes of glass each year that then gets recycled and made into new bottles and jars. And we're going to check out the process. So I've been hearing this word cullet a lot. Is that what we're looking at here?
So no, this is the waste glass that gets delivered to site. It's also got other household waste mixed in before it gets reprocessed in the site. It gets all the contaminants removed so we can have good quality cullet to use to be remelted for other packaging in the furnaces.
So can you tell us a little bit about the sorting process and how we get from this to the cullets?
Yeah, so waste glass gets delivered from various curbside, bottle banks and hospitality trade on site. We check it then to make sure it's of suitable quality. And then it gets loaded into the main hopper via the JCB telehandler. It then gets run through the plant. It goes through a series of magnets which takes away all the metals. The plastic and paper gets taken from a picking belt and through an extraction system. It then runs through shaker beds, which sorts it by size and then goes through our advanced optical sorters. They've got a light source, a mirror and a camera, and they go over in a waterfall effect over the light source and the camera reads it. So the green and the amber go straight through, the flint is positively rejected, as is the waste product. The flint goes into one side, the green and amber into another, and the CSP waste product go into another chute. They all go down the final product into the stillages. They get quality checked every hour, and then when they're good quality, they get used back up in the furnaces.
So how long does this process take to get from this, what we see here, to the cullet?
So it takes approximately 8 to 10 minutes to get loaded into the hopper, to run around the plant, to then be in the final product stillages. Those stillages then get emptied into the skips, and once we've got a skip full, then it goes up to the furnaces to be used.
Wow, that's really fast. By using cullet produced from recycled glass, like the cullet made here at Beatson, it means less raw materials are used in the furnace to make new glass bottles and jars. To give you an idea of how much it helps, for every 10% of cullet used in the furnace, we see a 5% reduction in CO2 and a 3% reduction in energy consumption. All the glass that comes into Beatson can be recycled over and over again, meaning it can come through the plant a limitless number of times. Here in the UK, it's actually possible to achieve a closed-loop economy of glass. But we all need to do our part and recycle our glass properly, so places like Beatson can create more cullet to go around the recycling loop forever. So we don't have to rely on any virgin materials. The more we recycle, the more cullet we can use in the process. Let's head back over to NSERC to show you how the new bottles and jars are made from the recycled glass. All the ingredients to produce glass, including the cullet, are blended together and then fed into the furnaces. The glass mixers are then sent to a number of different lines, depending on their type and colour. This glass then forms what's called gobs and is cut to size, depending on the container. This then goes into the forming machines that forms the final shape of the bottle in a blow mould. They're then conditioned to get the final chemical characteristics of the glass correct. After which they're inspected to make sure there are no defects before the freshly made bottles are sent to the filling hall, where some of them are filled with wine, beer or spirits that have been brought into the factory ready for distribution to be transported all over the UK. So why might these brands choose glass over, say, plastic?
Glass still wins in many factors in terms of when it comes to choosing a bottle. So when consumers are asked, they always choose glass for quality. You'll often find premium products such as wine and spirits in particular in glass. The glass is a material, this is where it comes into its own. So glass is the only material that's inert, chemically inert, so it won't interact with the food or beverage inside. So if you get a soft drink, for example, and you drink it from a plastics bottle, you'll notice that the taste can be a little bit different, a little bit off. And that's because the material, the chemicals from the layer, from the plastic liner, is interacting with what's inside the material. So with glass, it never interacts. It's the only mainstream packaging that doesn't change the taste. So for that, it's the best for health as well. And I'd say it's best for recyclability and best for that being that infinite material that goes around the recycling material chain again and again and again. The issue with glass is our carbon intensity. So that's the only factor when compared against a tin can or a plastic bottle, where we do fall down a little bit. So what we need to do is decarbonise our furnaces, which there's lots of work happening in the UK right now. So in the future, we think we can create zero carbon glass bottles, which will remove that last factor that goes against glass in terms of sustainability.
Innovation is a continuous process to make glass as sustainable as possible, both in the production and the design. For example, glass is 40% lighter now than it was 20 years ago, meaning less weight in transit and therefore less strain on the environment. And factories like Encirc are constantly looking for new ways to reduce their carbon footprint to produce this amazing material. We all just need to make sure we do our part and recycle our glass containers correctly. Now you know how glass gets from your house to the shop floor in less than 30 days.
Oh, thank you so much. So I didn't know if you all knew that you're going on a tour through a glass factory this afternoon, but how amazing was that? Has anybody ever seen anything like that before? Did you even know how glass recycling worked? Because it is so important that we recycle glass, because if a glass bottle gets sent to landfill, so if it does not go in the correct recycling, but just goes in like the normal black bin, this item will sit in landfill for pretty much ever. It will just stay as it is. But if the same item, this same glass bottle, is put in the correct glass recycling container, it can be back on the shelf within 30 days. So you might put this into glass recycling today at home or at school, and by the beginning of January, you could be buying it again full of your produce. How amazing is that? Glass can also be recycled up to an infinite amount of times. It can keep going through the same loop of recycling as many times as we like. Excuse me. It is such an amazing substance. So that is why we need you. So don't forget, I'm just going to give you this email address again, because we would love to have as many competition entries as possible. So the competition entry email is Glass Explorers, so GlassExplorers at Britglass, so that is BRITGLASS.co.uk, because I'm going to fully explain what we are doing, and we are looking for those winning entries. Take a photograph of them and pop it over. The team at British Glass and myself are going to look through all of those entries. The winning entry will be shared across British Glass, so they're going to put it in their newsletter, they're going to share it across their social media, and you are going to be in line for a £50 Amazon voucher. So do make sure we get those entries sent in. So remember, the whole purpose of this session is that you guys are going to become glass explorers. You are going to work in your teams to create a brand new school initiative that's focused on glass recycling. You are going to design eye-catching posters that can be designed around the school, put up around the school or in your local community, obviously with permission. We want this to be super creative, but also research led. So we've given you lots of facts in that video, but I am going to give you even more facts to include on your poster. We want to promote sustainability, but we also want to promote that we can show that you guys can be empowered and can create change within your local area. You might be sat there thinking now, oh, why should I pop this glass bottle into recycling? But you can make an absolutely huge difference, because if just one person pops it in, and then if everybody in your class, and then everybody in your year group, and then everybody in your school, everybody in your local area, everybody in your county, everybody in your country, the effects are absolutely huge. So never ever think that you cannot make a difference. Okay, so in your teams, you should have a team captain. I need your team captain to be ready with a pen, because I am going to give you some top facts about glass that you are going to include on your poster that you are about to design. Okay, you can all work on one giant poster and maybe sellotape them together, or on one huge piece of paper, or you can all work on your own individual posters. It is whatever is best for you. Okay, so are you ready? Because I'm going to explain what glass is made from. So guys, you're going to need somebody who can take some notes. Okay, so glass is made from sand, it's made from soda ash, and it is made from limestone. Okay, so glass is a material that is made from sand, soda ash, and limestone. It's commonly used to make bottles, jars, windows. Try and have a think in your team. Look around you. What can you see that is made from glass? Okay. I also want you to include, as I was saying, what happens when we don't recycle glass. When we don't recycle glass, it ends up in landfill. There, it just creates a big area, on Earth, where it will just sit there forever in a big mountain of rubbish. Okay. It does not break down naturally, so it just sits in that landfill forever. It also wastes resources, as they were saying in the video. Making new glass uses lots and lots of energy and what we call raw materials, whereas if we recycle, it means that we can keep reusing this material right here. Transporting and making new glass as well creates air pollution, carbon emissions, which can contribute towards climate change. So just be quickly making a note of these, okay? Are we ready now for our top tips of why should we recycle glass? So again, your team captains, make sure we're taking notes. I want you to include these on your poster designs. So why should we recycle glass? Recycling glass is one of the best things that we can do with the environment, and I'm going to give you some top tips why. It saves energy, and I think you'll all really enjoy this fact. Recycling one glass bottle like this saves enough power to power a washing machine for 10 minutes. How amazing is that? So just one glass bottle. It reduces pollution. So less energy means less pollution into the air and fewer greenhouse gases. It protects nature. So by recycling, we're using fewer natural resources like sand, like limestone, like soda ash. It helps to create new things. So recycled glass can be turned into new bottles, it can be road surfaces, it can be tiles, it can even be installation for homes. So guys, what I want you to do is, in your teams, I would like you to make a start on your Glass Explorer poster designs. As you are doing that, I am going to let you have a few more facts. So make sure you're listening out so you can add those into your brilliant poster design. Don't forget, we are trying to lead an initiative that happens within your school and in the wider community. We want everyone to be recycling glass. And I hope you noticed during that video as well that you were watching thinking, wow, I might not even have ever thought of a career within the glass industry. There are so many different careers within the glass industry. Really interestingly, in Sheffield in South Yorkshire at the British Glass Lab, it's currently run by a full female team of chemists working in their lab, which again I think is really, really inspirational. You don't even have to just work in glass recycling. It could be that you become a glass artist. They also have a number of apprenticeship opportunities as well. So if a career in glass is something that you are interested in, again, make sure you check with your adult. But if you put British Glass into YouTube, there are a number of videos on there showcasing all of the different careers within the glass industry. Also, if you enjoy this task today, between British Glass Technology Services and Amazelab, we have started to put together some curriculum-linked educational resources. So there are Glass Explorer activity packs. So again, as teachers, if that is something that you would like to explore, please do just contact British Glass. via the email address provided that we're using for the competition, and they will be able to provide you with completely free of charge educational resources that can be used in your classroom. Right, guys, so I hope that poster is taking shape. So don't forget, your task is to design a really eye-catching poster to try and get everybody in your school or local community recycling glass. Okay, as you're doing that, I'm just going to be giving you a few more top tips. So remember, glass is far too valuable to waste. We need to recycle it to protect our planet, to save energy, to reduce pollution. Every single glass bottle that is recycled is a step closer towards a greener and cleaner future. I'm going to give you some more top tips. Okay, so what exactly is glass? So glass is a hard see-through material. We know what glass can make, and we also know what it is now made of. One of the best qualities of glass is that it can just be recycled again and again and again, which is absolutely brilliant. So make sure we are getting that down on our poster. Okay, if you want to come up with catchy slogans with big headings, that's absolutely fine. And please do make sure that you include on there that recycling glass may be a really, really simple action, but it has an absolutely huge impact on the environment. Okay, I will find you a few more facts to share. Okay, so why have we set you this challenge? Because at the moment, too much glass is going to landfill. Even though glass is 100% recyclable, millions of tons of glass end up in landfill every year. What does that mean? It means it's being thrown away instead of being reused. And we've actually got some facts from British Glass to share with you about that. And I think you might find some of these pretty shocking. So in the UK alone, over 300,000 tonnes of glass was sent to landfill. All of that glass could have been recycled. That's more than enough to fill 30,000 double-decker buses. So try and imagine, if you've ever been to London and you've seen all the London buses, imagine 30,000 of those buses filled with glass that went to landfill instead of being recycled. Nearly all of that glass could have been recycled and turned back into jars, bottles, even into road surfaces. So why is this happening? Why are all those people putting their glass bottle into the bin rather than into recycling? Well, sometimes people throw glass into general waste bin instead of recycling bins. Sometimes it can be that people haven't thought to do that, or they didn't want to wash it out, ready to go in the recycling bin. We want to change that, make sure it's on our posters. It could be that some areas still don't have really good recycling systems, so there's not a separate bin that glass can go in. Sometimes broken glass can be really hard to sort and recycle when it's mixed with other rubbish, so sadly, it ends up going into the landfill system. So what can you do, and what are you going to do to promote people recycling glass? So this is what we really, really want to get across. How can we stop glass going to landfill? So please pop on your posters, always putting glass bottles and jars into the recycling bin. Rinse them out before recycling so that they can be recycled. And why not have a go, again with adult permission, about reusing glass containers at home? You could use them for storage or even for crafts. And make sure as well that you talk to family and friends about why recycling glass is so, so important. We also have another fun fact for you that the British Glass team shared with me. So again, you know, we said about powering a washing machine. Some of you guys might not quite be using a washing machine just yet. So we also found a fact about computers. So one glass bottle saves enough energy to power your computer for 25 minutes. So it's definitely worth recycling your glass, isn't it? Right, team, I'm hoping you are all going to become glass heroes.
I hope so.
Glass
I hope we've got some good
explorers.
posters. I'm not allowed, I don't think I'm allowed to enter the competition and win the £50 Amazon voucher.
Oh, Oh, of
Hey,
course you can. We'd love to see your entry. Absolutely.
you know what I was
love to
thinking?
see.
You know what I was thinking when you were talking about all the different things that glass is made of? I was thinking about glass is made from sand, and sand is everywhere. The fact that we can take a bunch of sand and make something like a silicon chip, which is the thing that processes a computer, which is the thing that processes AI, which is about to become conscious. Like, we've made glass think. It's like crazy. Isn't that crazy?
I know, and they were saying when I've worked with the British Glass team, and we've been in person in schools, we basically bring the glass recycling plant to the school. So they bring the glass. The sand is amazing. It's like a bit like a silver with platinum colour.
Yeah.
That they use, and it's absolutely fascinating. And they've got a brilliant 3D printed artwork. So in the school hall, we can all walk on it. We bring like the personal protection equipment, the PPE, and we put all the jobs from the glass factory, because sadly it's very difficult to take lots and lots of young people around a glass factory. That's why they made those wonderful videos, so you get a real feel of it. But it's so important to recycle glass. There's no excuse really.
No, there isn't. I was thinking as well about long time ago. I mean, when we think about glass, you mentioned windows and bottles and jars, of course. In the 1600s, there was this guy in Italy, and his name was Galileo Galilei, and he took some glass and he used a cannonball to grind the glass into a lens. And then he had a couple of those lenses, and he made a little tube out of it and didn't invent, but you made the very first telescope. And actually the telescope then revealed the universe to us. And then, of course, it got better and better. And of course, we have glass in our phones that allow us to, it's just this, it's a miracle material. And we take it for granted. And thank you for making us not take it for granted. That's all I was going to say.
Oh, it really is, and it's absolutely fascinating.
I'm getting misty-eyed over glass.
Yeah.
Sorry.
It's absolutely fascinating. I'm so sorry, guys. I've got an horrendous cold today. It's absolutely fascinating where you find glass. So in wind turbine blades, fiberglass, in solar panels. The British Glass team work with a team making and recycling solar panels. You find it in makeup. You find it in toothpaste.
Makeup.
They store radioactivity
Yes,
in
that's
glass.
true.
It's absolutely fascinating. And until you work with these teams of people, you don't realise what a versatile substance it is.
If anyone wants to get really niche, and I mean really niche, there's a really good Werner Herzog film, 1976, called Hearts of Glass, about a Bavarian glassmaking village, and their chief glassmaker dies and has forgotten to tell everyone how to make the glass, and so the village just they can't make glass anymore. That was completely niche, Leonie. You don't need to watch Hearts of Glass, but it is very good. Are they showing us their posters? How do we win the prize?
Yeah, so
what's going on?
What will happen is, I don't expect everybody to complete the posters now. We want to give them a start, because I know they'll want to take time and be really proud of them. Obviously, if they can turn on the cameras and show us, they are absolutely welcome to. Please do. But if you would like to continue on with them, we would really like for your teacher or your adult to take a picture of them and then send them through to the Glass Explorers email address. And then the team will pick a winner, and then they will receive their prize.
How long do they have? So when do you need to get all the, do we have a sort of closing date for
they can have all the way up till Christmas. There's no rush. They don't have to do it by today.
Okay, so you've got until Christmas, ladies and gents, boys and girls. Get your glass posters, and presumably they've got to be eye-catching. A good poster. You've said all the things you want to have on it, but it's got to grab people's attention.
Yeah, we want them to be really creative, but also research-led. So they've got all the facts on those posters, and ideally we'd love them to be displayed around school, even if they could run an assembly on it, if they could go into the weekly newsletter, and we're really hoping to spread the word about glass recycling.
I think it's great. And have a think as well about all the different uses that glass has. We've named a few. I think about things like lenses and just how revolutionary lenses have been in science and engineering. Also in science generally, glassware is so vital in things like chemistry for all kinds of reasons. And actually it's you mentioned it earlier on, how beautiful glass is as well. I'm going to stop talking about glass because I could just go on about it, because I'm a glass fan. Well, that's it. So that's it, Leonie. Are you all done? Have you got more or...
So I've been asked to leave the rest of the time for questions. So I have got
okay.
more facts
Well, let's
if
have a look,
anybody
shall
wants
we?
them. But yeah, so we really as well just did want to get across that there are so many different careers in this industry that they may not have thought
Great.
of. As I mentioned on the British Glass YouTube channel, obviously again with adult permission, there are a number of videos that show different careers within the glass industry that you may never ever have thought of, but there's loads of apprenticeship opportunities, so please do have a look. Yes, I think this time is open for questions. If anybody's got any, I will try my best.
We've got one. Mrs. Teasdale's got a very good question here. What happens to the labels on glass bottles?
Oh yeah, at the recycling plant.
Yeah,
so
I think so. Yeah, I think that's yeah.
So that is all part of the sorting process. It's a really, really clever sorting process where the glass actually gets all, before it gets put into the different colours, all of the labels are removed. And then you probably saw on the conveyor system as well, anything that's been left behind will then actually get sorted. So any labels that are left on those bottles will then go into a different section. And it's actually a really clever system again, because it then can read the colours of the glass to which recycling pot they need to go into. So glass is quite often different colours, really depending on chemistry. So people who work in the lab in Chapeltown in Sheffield, they undergo a number of different tasks. So they've even had a task where in a supermarket the champagne bottles were exploding and they didn't know why. So the team had to research all the glass that those bottles had been made from to make them nice and safe again. So they do undertake some quite exciting research tasks, like things that you might not have thought of. But yeah, that's why we have different colours of glass as well.
Champagne bottle, yeah, it's a good. There's some good engineering in the champagne bottle. Well, I suppose the at the bottom you've got that arch, that kind of bit of the bottle that goes in, which gives it strength under pressure, and then some bright spark to stop champagne bottles exploding. You had that wire thing that goes around the cork. I only ever drink champagne. You know, that's all that's in my fridge. Very good champagne, Veuve Clicquot. We've got I'm joking, of course. We've got a couple more questions. How do people in the industry feel about the possible closure of the National Glass Centre? I didn't know that this was a...
Oh, no, I'd have to speak to the British Glass team about that, but I'm sure they would be more than happy to provide you with an answer. But I can put that question to the team at British Glass.
Okay, how many bottles can be recycled in one day? Well, they sort of covered that in the video, an awful lot.
Thousands and thousands, yeah.
It's just a crazy amount of things. And what happens to the bottle caps? Well, I suppose the same thing that happens to the labels. They get sort of sorted and what have you.
But that's another reason why it's so important at home when you're doing your recycling, that sometimes we just do put that bit of care and time. So if you do have a glass bottle, the lid is put in the correct recycling and it's washed out and then popped into the glass recycling bin, because sadly some things that are put in are sorted and then aren't suitable. So even though it might take us a few more seconds, it's definitely worth just taking that time to make sure that things aren't going to landfill and that they can be recycled.
I am guilty sometimes of not recycling properly and things going in the wrong bin. I get confused and rushing around. So if we can all be better at recycling, that would be good. Well, we've sort of come to the end of our time. We've got a couple more minutes. Just very quickly, just tell us very briefly about Amazelab and about what it is and how you got involved in it. Your career as a STEM ambassador and a science communicator.
Oh, thank you. So I actually started life in STEM industry. So I started out in veterinary practice.
Nice.
Yes, so I used to work in general practice. I used to work in orthopedics. I used to work in rehabilitation. I honestly used to swim dogs for a living at one point.
You used to do what to dogs for a living?
Yeah, doing rehabilitation, which was absolutely amazing. And then I used to train veterinary nurses. And then I actually retrained as a science teacher. So I've got a chemistry specialism and I worked in primary, secondary and post-16. I'm now a proud company director of Amazelab. So at Amazelab, we try to use creativity to break down barriers to learning STEM subjects. So we create educational resources, but we try to make everything super fun and interesting. So an example of that is I was in a secondary school this morning just to try and inspire those amazing young people into a career in STEM. But I took my dry ice along with me just to try and create that real buzz and excitement. Yeah, I'm a very proud STEM ambassador as well. I'm very lucky to have won a number of awards in that. So yeah, I volunteer a proportion of my time trying to inspire young people into these amazing subjects.
You've done a great job, and you've done a great job, and you've done, and what an interesting subject as well. I just think it's absolutely fascinating. I'm one of those people that's just, I'm infinitely fascinated about how things work and how things are made, and I love getting really deep into the kind of granular detail of it. And you think, you know, something like glass that we take for granted, it's completely changed the world on multiple levels, all the way through from actually someone, Mrs. Robinson, thank you very much. She asked when was the first glass bottle made, and someone's replied 1500 BC. It's probably even earlier than that, I suspect, but maybe that's right. That sounds good. A while, basically, a long time.
We do actually have a rich history in Barnsley, where I'm based in South Yorkshire, of glass as well.
Yeah.
So these little hidden gems, you know, I'm from South Yorkshire, which really is built on steam and all STEM subjects.
Yeah, well, that's it. And you know, you dig around in your garden, you're always finding like an old sort of bottle from the 19th century or the 18th century, you know, knocking around, and it's really fun to see old glass. The little well, you know, this idea of, someone mentioned it earlier on, messages in a bottle. You know, you put your message and throw it into the ocean. They're these little time capsules. There's something rather lovely about that. Hey, there's something you could do at school. Write a message in a bottle. What would you put on a message in a bottle and chuck it into the sea? Although maybe don't chuck it into the sea, because you'll probably get into trouble by someone, not by me. Anyway, listen, Leonie, thank you so much for coming.
It's a pleasure. Thank you so much for having me.
Great pleasure. Thank you very much indeed. Right,
please don't forget about the competition.
There's a £50 Amazon voucher to be won. You can buy my Christmas present with that, or my new book, which is on sale for $49.99. No, it's not. It's but you'll be able to buy a couple of Christmas presents with that. So there you go. So thanks very much, Leonie. It's been an absolute pleasure. Right, okay, we are on to our final speaker now. We have got Ruth Amos, who is going to tell us all about kids inventing stuff. She has a really interesting story, a bit like Leonie. She's had a sort of roundabout, wiggly route into her journey as a science communicator. Ruth, are you there?
I am. Can you hear me? That's the next question.
I can hear. Did I read that right? You were going to be a lawyer, and then something happened. You like magically invented something, and then your life changed.
Yeah, kind of. Yeah, and weirdly, this is a very bizarre phone call because I know Leonie.
Oh, there you go.
And we have actually met Dallas as well at different events in the past.
Yeah, so I was going to say we've met before, and I'm sure I've met Leonie before as well. But you know, maybe in, you know, yes, exactly, around and about.
Yes. So yeah, I'm going to try and attempt to share my screen. Who knows as well if when I'm trying to share it will share sound or not. But we will give it a go. We will test.
It's one of the great mysteries of life. I always wonder about this, Ruth. Actually, it's you know, we invent miracles. AI we've invented, and I just want to tell these people, just get screen sharing sorted first, get printers working, and then do AI and all that. But look,
can you see this? Is it working?
It works. Fantastic. Because the good people at RTC North, Zara is a genius.
Does it work if I do this or not? Does that stop? Because I can't see any of you.
No, it works. It's great.
Oh,
it's working.
Perfect. Okay.
Hopefully
amazing.
We've got sound. I'm going to shut up now, and I'll hand over to you.
Before I'm going to reshare again properly. But first of all, just while I can still see you in the chat, could I have, if you are a primary school, can I have a thumbs up? And if you're a secondary school, can I have a heart? Just so I can see roughly if you're able to type in the chat, primary or secondary. That'd be great. We'll give you a bit of time for that.
Lots of teachers are now rushing around.
Are you primary or are you secondary? Primary. Perfect. Typing it is also acceptable.
I'm going to call myself primary.
Yeah. That's perfect. Oh, we've got some secondary here. Okay, we're a mix. I can already see we're a mix. Fantastic. Okay. So let me introduce myself. So my name is Ruth, and I wear a number of different hats. I am an inventor and engineer, and was mentioned earlier, I accidentally became an inventor. So when I was at secondary school, my teacher challenged me to invent something to help his dad go up and down the stairs. And before that, I thought I wanted to study law, and that experience, I ended up winning an engineering award and bringing a product to market, and it completely changed my view on everything engineering, inventing. And from that, I've gone on to do lots of other things. But one of the main things that I do is I make YouTube content. So I'm sure some of you watch YouTube. Some of you might not be allowed to watch YouTube, but essentially YouTube allows me to create lots of amazing content all around STEM. And I'm going to talk a little bit about that in a bit. I'm also an author. Essentially, any chance I get to talk about inventing or making or how things work, I will take it. So I have a book all around 10 inventions that changed the world and some of the amazing people that fed into that. And as an inventor, as someone that is constantly trying to do new things and push boundaries, you often end up doing things that are world first. And so I have a number of Guinness World Record titles, mainly around my work on YouTube. So I will come on to that in a bit. But quite often when we're doing things that are new and exciting, they can feel quite scary. But at the same time, we can end up doing something that's a world first and becomes really exciting. So this is where it all started. I know we've got some secondary school students on the video, but this is I think it was my year 10 school photo. Little Ruth did not understand about engineering. Unfortunately, I did not have amazing days like this to learn all about incredible STEM companies and activities, and look at some of the problems that we need to solve. So I didn't really understand engineering, but I had an amazing teacher, and he challenged me to come up with something to help his dad go up and down the stairs. And so when I was 16, I invented something called the Stair Steady, which was a specialist handrail that helps people go up and down the stairs. And it was the first time that I'd ever seen anything that I'd drawn on a sheet of paper come to life. I have to say, the first prototype was a scaffolding pole and a block of wood. These are very lovely, fancy diagrams that were created a long time after my first classroom project. But this product really started in the classroom, and it started from an idea and from a challenge. And it really got me thinking about being an inventor and about solving problems. And one of the things that I really love about being an inventor is I'm the sort of person that looks at stuff and goes, how does that work? Why do we do it like that? I ask a lot of questions. I have a 6-year-old and he also asks a lot of questions. And I think it's a really good skill to have. But I kept asking myself, why do I love being an inventor? And it's mainly because, now this is a very depressing slide, I promise it's only up from here. But that's because we have lots of problems that we have to solve. Some of them are really big problems. We've been hearing today about climate change and recycling. And this looks like a slide of lots of really big things that might make us sad. But actually, each one of those situations is a chance to do something new, to create something exciting. And that's why I love inventing and coming up with engineering solutions. And sometimes when we look at the world around us, particularly at the moment, there is some amazing technology. When I was your age, if I thought now that we would be looking at driverless cars or robots that can stand and run and carry things, or super fast trains, or computers that fit in the palm of our hands, even things like our smartphones, the amount of technology that we're able to carry around in our pockets is absolutely incredible. And I always thought that things like this were designed by really clever, smart people. And yes, those people are very clever and they are very smart, but actually, a lot of the time, they started like you and me, interested in things. They loved making things. They loved days like this, hearing about how different things were created, the stories behind them. And actually, I've met a lot of those people who've done amazing things and designed things that affect our lives every single day. And I'll tell you a secret. As passionate as they are about the thing that they've designed or invented, they are people like you and me. And for a lot of those people, it's not just about how well they did at school. It's about the fact that they saw something and they had an idea of how they might change it or make it better, or they saw two things that existed and decided to smush them together to create something new. And so I often think that we look at these amazing things that are in our lives. You know, as part of the book, I looked at light bulbs and the bicycle and the computer, and we see these lovely, shiny, polished things. And actually, so many different people, so many different ideas went into those things. And it's really amazing when you start to break that down, because often it's just one little idea, one quite simple thing that was then taken by someone else and developed to end up with some of this incredible technology that we've got today. But what on earth does that have to do with my job? So my job is a little bit interesting. One of the things that I learned when I was at school, and I did this drawing of my product and I saw it brought to life in a factory, and I ended up bringing it to market and selling it to people, is it made me realize that lots of things that we use every single day aren't designed by a group of special people that we never get to meet, that are locked in a room. We could be one of those people. We have amazing ideas every single day, and those things have value. And so me and my friend Sean, we realized if you're an adult, you're a little bit older, then, and some of you watching this at secondary school, you will probably potentially have the tools to be able to build your idea. I was really lucky. I was able to build a prototype of my invention and kind of prove that it worked in the classroom. But if you're slightly younger than that, you might not have the ability or the access to be able to do that. But what you do have is some really good invention ideas. So me and my friend Sean, we would go into schools and we would find that 4 to 11-year-olds would have incredible ideas. And they'd be like, oh, I've had this idea, because this is the thing. If you tell someone you're an inventor, they want to tell you their idea. So I have heard hundreds, if not thousands, of people's invention ideas. And top secret, but adults' inventions are usually quite boring. Children's, young people's inventions, well, they are much more exciting. And me and my friend Sean, we were like, wouldn't it be really fun to show how engineering works, how STEAM all works together by building some of these inventions. So we set up a YouTube channel called Kids Invent Stuff, where we get sent amazing invention ideas, and each month we bring different ones to life. So this is the bit where either the sound will work or it won't. So let's see, shall we?
I'm Ruth, a patent-holding inventor and maker.
And I'm Sean, a designer and engineer.
And we believe that kids have the best invention ideas.
So join us on our mission to build kids' ideas, make mistakes,
and show that anyone can be an inventor.
Kids invent stuff.
Hopefully you heard that. If not, essentially, it's an introduction to what we do on the channel, taking kids' ideas and bringing them to life. So I'll take you through the whole process of what we do. So this is 11-year-old Lila's popcorn doorbell. Now, sometimes we will take invention ideas that already exist, like the doorbell, and we think, what are ways to make it better? Sometimes we're creating brand new things, but we thought doorbells, often they're a little bit boring. You might have a fancy one that, you know, you press the button and it has a camera, it makes a noise, but actually, as an engineer, I know the buttons can be really exciting, because what happens when you press a button is you can make something amazing happen. And so that's what we set as an invention challenge. And this is 11-year-old Lila with their popcorn firing doorbell.
So we built the world's first popcorn doorbell.
Invented by 11-year-old Lila.
Let's test it.
Kids invent stuff.
Thank you for activating the popcorn doorbell experience. Your popcorn will be with you shortly. Activating popcorn. Thank you for visiting. Thank you for activating the popcorn doorbell experience. Activating popcorn. Thank you for visiting. you for activating the popcorn doorbell experience. Activating popcorn. Activating popcorn. Activating popcorn.
So there we go. That was the amazing popcorn firing doorbell. And we bring to life all sorts of different invention ideas, but the rule is that it has to have been sent in by a 4 to 11-year-old. And you might be looking at this and thinking, where is the engineering? Well, every single video we show how something's made. We show the things that work, the things that don't work. And as part of that, that is what engineering is about. And we use lots of different types of engineering. So sometimes we show a bit of chemistry. Sometimes we show a little bit of fabrication, a bit of welding, a bit of woodwork, all sorts of different things. But we personally believe that kids have the best invention ideas. So 6-year-old Ella's baby walker for adults, so you can do business on the go, business. We've got Aria's robot chicken. Now, this was actually a very special invention idea. This was our 100th invention. And we realized that actually we had managed to have 99 inventions built and tested on Earth. And so we wanted to do something super special for our 100th invention. And so we sent 8-year-old Aria's robot chicken to space. Now, this was not just a normal chicken. This was a robot chicken, and it pooped sprinkles on the Earth to celebrate our 100th invention idea. Now, as you can imagine, doing something like sending something to space had a lot of problems. We had to think about the weight. We had to think about the way that it worked, because when you're up in space, it's cold. The atmosphere is different. And quite often when we're building these invention ideas, we have to think of lots of other problems. We have to solve lots of problems to get there. We've got Alex's furry electric dog car, the future of electric vehicles. And we've also, see if that's gonna, there we go, Alex's giant furry electric dog car, Doggo. So Doggo was all about how do we think the future of electric vehicles might look. And it has an amazing tail that wags, and when you press the horn, it woofs. And yes, we loved it, and we loved people's reactions to it as well. I think quite often it's about thinking and looking at the world differently, and we realise that lots of you already do that, but sometimes us adults are a little bit stuck in our ways, and so it's nice to really get people thinking out of the box, because we know lots and lots of you have amazing ideas. Now, I have to say, this is not the full 100, but if you look at those thumbnail pictures, many of them are very messy. A toilet cleaning robot, a jam firing rocket, a giant robot dinosaur that mops the floor. Lots of these inventions fire things, but actually one of the other main themes that we get, we kind of have lots of food, so you saw popcorn firing doorbell, lots of mess, but also one of the things that you are really interested in is inventions that are good for the environment. And so we get lots of amazing green inventions, just like trousers that plant seeds. So this was a challenge all around Wallace and Gromit's The Wrong Trousers. These are the right trousers. And as you walk along, they plant seeds. We've got the battery dog. So this was, I don't know if many of you know around different types of energy we might have in our houses, but Octopus Energy work a lot on green energy. And so we partnered with them. And we took lots of amazing invention ideas, and we ended up building a robot dog. So as you walk it around, it can recharge, but you can charge it through solar panels, and you always have energy on the go. Also, it is the perfect pet because it makes a lot less mess. We've also got the carrot car. Now, this is different to the dog car. This is actually made around a bike. So this is made around a recumbent trike, and it does have a motor in it. It's like an electric bike, but this is actually roadworthy. So when we tested this, we drove this around the streets of Cornwall, much to a lot of people's surprise. But the carrot car fires out wildflower seeds and bird seed. So as you're driving along, you can fire out the seeds, and then maybe on patches of ground that don't have any flowers, because we know they're really good for the environment, for bees and things like that, it will fire them out. But also as a car, it's very good for the environment because you can pedal it along rather than having to use any fuel or things like that. We've also built a wind turbine. Now, I'll have to be honest, when I first looked at doing this project, I realized that I'd not really paid that much attention to wind turbines. I'd drive past them and I'd see them. And as we started to do research for this project, I realized that quite a few people seem to think that wind turbines are quite ugly. And so as part of this, we decided to ask young people to redesign them. And so this was an octopus wind turbine. And there's so much that goes into that. I suppose naively, I looked at a wind turbine and was like, oh, it kind of just spins and creates energy. But there's so much more that goes into that. And this is a really fun project to learn how that all works. So if you're interested in any of these, there's obviously full videos on the channel. But I know that today you've learned lots about some amazing net zero stuff and hydrogen and Leonie with the glass. But what I hope that you will take away from today is that you might have different interests to those in your class. There'll have been different talks and different things today that have inspired you. And that's really interesting because we all have lots of different skills. So there's lots of things that we're good at. And even as an inventor that makes things, I have different skills to Sean. So I do a lot of welding and fabrication. And quite often you'll see Sean does bits of, we do lots of cooking. We once baked a gravity race, we baked a car. And so everyone has different skills. And so don't be afraid to celebrate your skills, even if they're different to your friends. Also, there's a place for you within kind of engineering and inventing. There are so many different jobs. And I think Leonie touched upon it a little bit at the end of her talk. But I know so many different engineers. So I have friends who work at Lego, who design cars. But then within those particular, even those particular jobs, you know, one of my friends is a material engineer. She looks at the types of material that we use to make cars faster and more energy efficient. I have friends who help design buildings. I have friends who work in engineering who work at a computer. I have friends who work in engineering who work in a workshop like this. There's lots of different types of engineers and we all have lots of different skills. And so if you want to have a job within this industry, there is definitely a place, whether you're really practical and you like to build stuff, or whether you like sitting down and doing the calculations, or you like both. The nice thing about engineering and particularly some of the challenges that we have to face around net zero and the climate and making things more efficient is that we need lots of amazing people with lots of different skills. And it doesn't matter what subjects you feel like you're good or bad at school. I'm dyslexic, and so one of the things that I never thought I would do is I never thought that I would write a book, because even when I was at primary school, I really struggled with my spelling. And so to have done that and to have worked with the publishers to write a book was a really big achievement. And I felt really proud. I don't know about you, but when I do something that I'm a little bit scared or nervous about and I face it and I do it anyway, I feel really proud about that. And so my book is one of the things that I feel particularly proud about, because it's something that I struggled with and was able to do. And the same within lots of building. When we build things always go wrong. There is a cycle within building and making where things don't work out. In fact, I'm sat in my workshop now surrounded by broken pieces, things that I have put together and haven't necessarily worked. And what's really interesting is as I start to look around my workshop, some of the things that didn't work for my last project will be really useful for this one. And this is the thing about engineering and making things and problem solving is the only thing you can guarantee is that at some point something will not work and something will break. And so it's really important to think about how we deal with that situation, because I personally find it very frustrating when I've made a plan and it doesn't work out. But actually, I learned so much more than if everything had worked out perfectly. And in fact, I often think that sometimes when we see something go wrong and we find out why, that is something really useful. And you can bring that to your next project or the next thing you do. But actually, when we see something fail or not work, it's really important that we don't see that as a negative within the project. But one of the key things I think is that everyone can be an inventor. And I did joke earlier about adults having rubbish ideas, even teachers, even you will have amazing ideas. But I do think there's something really exciting that young people have. And it's that sense of curiosity and quite often that problem solving and creativity, which are all amazing skills. They're skills that we need as we go out into the wide world, whatever career you're in. If you are a great problem solver, if you can look at a problem in a different way, that's such a great skill to have. And so it's something that we shouldn't lose. And I think sometimes as we get older, it's maybe something we don't practice as much. We don't look around the world with the same curiosity. Dallas and Leonie and myself are really lucky that the work we do allows us to stay curious and to ask loads of questions. And that's something that I would love for you to keep doing and practicing and thinking about and making it a part of your kind of everyday, is to be curious and to look at those things. What sometimes people ask me, how do I be an inventor? And one of my things that I say is just make a note of the things that annoy you, of the problems that you see, and that's a really great place to start. So when I was designing Stair Steady, the mobility product, it wasn't my problem, but it was a problem that my teacher had seen. It was something that he had witnessed his dad. His dad wasn't able to go up and down his stairs. And so my teacher challenged me to invent something to help him be able to do that. And so that's a really good way to start, is to, whenever you're getting frustrated with something, you look around and you think, oh, that's not working, or why does it do that? Make a note of that, because at some point you might have a solution to that problem, or you might think, actually, I know how you could fix that. And being able to do that is a really important skill. Now, I've managed to open this on my phone as well, so I should be able to get some of the notifications from you as well, which is very exciting. But I know that there's going to be time at the end of this for questions and things. So I'm just going to give you a few moments now to have a little think in your classrooms of some questions. It can be anything. It can be about kids invent stuff. It can be about being an inventor. And I'm going to stop sharing this with you so I can see all your lovely faces, or at least your lovely icons. How do I stop sharing this? There we go. Oh, there's loads of questions here. Amazing. We've got lots of thumbs up, some hearts there as well. Thank you. You could hear it fine. That's great.
This is a great opportunity to plug your book. It's Christmas coming up.
Oh, thank you. I know. Well,
come on.
Yeah. So
let's go.
Inventors Workshop, 10 inventions that change the world. Yeah. I'll even sign it if you buy it off my website. Very exciting.
Can I? I've got a question. Out of your 10 inventions that changed the world, I had a podcast for a few years called Patented, which was about the history of inventions. So you've reminded me of all these things. What's your favorite one that you came up with, or maybe not favorite, but the one that really kind of perhaps affected you the most?
So the hardest thing was getting it down to 10. If any of you want to know the secret of how you write a book, so what happens is when you have a publisher, they say, it's a bit like being at school. Do you know what? As an adult, I realized there are things in school that have prepared me for being an adult. But you know, at school, they're like, write a plan. Well, that's what you have to do for your book. And you have to kind of work out what you might include in it. And so I did lots of research on lots of inventions. And the hardest bit was just getting it down to 10. But the one that really, I think, kind of resonated with me and surprised me was when I was learning about the bicycle and how that had been used to really change and pave the way for women. So, for example, when the bike was a mode of transport that women were allowed to use. And so when it came to women fighting for the vote, the suffragettes used the bicycle a lot, but also other parts of the world, having a mode of transport that is green, that is quite cheap, has really been revolutionary and has really opened a lot of doors for people. And so for me, that was what was
Yeah.
I hadn't really thought about it in that way of what a difference if we hadn't had the bicycle, what a different history and what a different place and time we'd be living in. We often think about, you know, with the lights, we'd all be, you know, stopping work when it's dark or lighting candles and things like that. But the bike really made a difference in so many aspects of our lives in areas that we wouldn't have necessarily expected it to. So yeah. Oh, I can see lots of questions coming in the chat. This is what I'm liking.
I don't know. Do you know, just while you're on the bicycle, there was, I don't know if you know Kat Youngnickel. She wrote an amazing book and she found all the patented rules. When the bicycle was invented, and you mentioned the suffragettes used the bicycle, there was also an explosion of invention by women of clothing, of functional clothing that could be used on bicycles. So skirts with things that you could pull, which would suddenly turn them into trousers, so you could ride a bike. It's an amazing, amazing book. Kat Youngnickel is her name. Anyway, there you go.
Perfect.
What's your best advice for girls wanting to enter the STEM sector? And while we're on the subject, what's the funniest invention? Oh, well, can you see all these questions?
Yeah,
Ruth?
shall I go through?
Okay,
do you want me to go from the top? And
well, whatever you want. Just pick the one that you want to answer, I guess.
I'm very disorganized. If I don't start from the top, I'll miss one.
Then start from the top.
Right, favorite invention. Here we go. That's really tricky to choose a favorite one. Usually, because it's the one we've just been working on, I usually just say whatever we've been working on. But I have been working on a top secret surprise one for near Christmas, and I do lots of different making, but this one involves some 3D printing. And I don't know if any of you in your schools have 3D printers. I love 3D printing. I also love Lego, and so I last Christmas scaled up the little Lego Christmas tree and I made it 6 foot and 3D printed it all. So I love 3D printing, and I've recently got a 3D printer that can print multiple colors, and so I'm very excited for the invention that we're going out near Christmas. So check out Kids Invent Stuff on the 21st of December, because I'm really excited by it, and it's part of our Secret Santa series. So unfortunately it's an invention I will be sending to another YouTube maker, so I'm quite sad. I might have to make another one because I really like it and it's very pretty. What inspired me to be an inventor? So I accidentally became an inventor. That the teacher at my secondary school, I went to a very normal state school on the outskirts of Derbyshire. I live in an ex-mining village. I'd never considered being an inventor. I thought it was kind of a job for special people. And actually, when my teacher set me that challenge, that's what kind of threw me into this whole world of engineering. I won an engineering award. I met other engineers, and I realized that actually anyone could be an inventor. What's the most important invention you've ever made? Ooh. I mean, the stair study makes a lot of difference to a lot of people. There's lots of the video I showed at the beginning of that little girl. That was the first time that she'd ever been able to use her stairs safely on her own. So I know that invention, although I don't always get to see that firsthand anymore, but that invention really does make a difference to lots of different people's lives. What's the funniest, weirdest invention you... So the great thing about Kids Invent Stuff is that actually you lot do the hard work. So we get sent about 25,000 kids invention ideas every single year. I had for a long time a room in my house that was just full of inventions, and then we got too many inventions and I have to have a special storage place to put them, which actually makes our job super easy and super hard. We have a lot of inventions to choose from. It's really tricky to choose what to make. So actually a lot of the inventions that I come up with are maybe not as exciting as that. But what are the funniest, weirdest things that I've seen on the channel? I think a lot of the things that make it very entertaining for me is people's reaction to them. So the 7-foot dinosaur that mops the floor does not really fit in any sort of mode of transport, and so often the way to get it to places is to drive it through the streets, and that gets some weird looks, or to strap it on the top of a car. So yes, that was quite interesting looks. I think the people that live near me are very used to seeing weird and wonderful things, drivable bats up and down the pavement, us testing some firing mechanism for some slime or something. What's the best advice for girls wanting to enter the STEM sector? Ask lots of questions, have a look around, try and find other women within STEM and find out what they do. I have a really good network of other women who are in STEM, and it's really useful and helpful. If you are, depending what age you are, have a go at making stuff, learn new skills, constantly be learning. I did not learn to weld until I started Kids Invent Stuff. I was a lot older than all of you then. And try learning new things, try practicing. You're not going to be good at something first time. Quite often there are, I would get frustrated because I would look, when I did design and technology, I was there was 2 girls in my class, and I would look around and I would see that the boys seemed to be really good at some of the things, and I felt I wasn't as good as that. And I learned that that's because I'm a perfectionist, and they would just throw themselves into it. So have a bit of confidence, but also understand that I would look around and I would realize that actually some of the things, I have very little hands, some of the tools there were not designed for people like me, because it's only recently that we've had lots more women in this industry. So don't let that put you off. Have a go, make things. You have every right to be a woman in STEM, and to be in that place and to build. And if you enjoy it, then that's amazing. Hardest invention we've ever made, every single one's hard in their own way. Unfortunately, resilience is a big part of inventing, and I know lots of schools talk about being resilient, but it's a really good skill to have, because failure is part of the journey. I was a perfectionist when I was growing up, and unfortunately you have to learn to embrace that failure. What's been your biggest size invention? Now this is interesting because I didn't actually go into which is the Guinness World Record, did I? These pictures are amazing. We have the world's largest electric toothbrush. So if you've got Guinness World Records 2025 book, the one that came out last year, you'll see it in there. If you have the current book, the yellow one, we have a Guinness World Record for the most popcorn cannons made and fired in a certain time. And we did that at a live show. And I'm really excited about that record, because schools, I think you could beat that. So we built popcorn cannons out of toilet roll innards and balloons, and we taped them on and we fired popcorn, and the number is not that high. I think some of you could beat that in an assembly if you fancied a go at a Guinness World Record. All of these invention ideas are absolutely amazing. If you have any other thoughts or you want to send me them directly, so I don't know if I'll have access to the chat, if you go on the Kids Invent Stuff website, there is a email on there. You can fill in your details and send it in, and there's a postal address, teachers. If you've got a whole class worth, send them over and we'll have a look through, and we might build them on the channel.
Ruth, we've got 3 here, which I think we could just got time for you to cast your judgely eye over them.
Perfect.
As an expert, have a look at them. We've got an infinite watering can.
An infinite watering can,
classic.
Nice. Yeah.
A paintbrush that paints all the colours of the rainbow in one brush and doesn't need to be
Oh, I
dipped into
love
water.
that. Yeah.
That's definitely built. What's this one? Seed rocket parachute. Well,
wow.
Place the rocket anywhere you like and it'll go up in the air and activate a parachute and scatter seeds all over the ground.
I love that. I feel like, do you know what? The seed rocket one, I mean, if Leonie's still on the call, she'll be adding that into a workshop. She loves a rocket workshop. She'll be sending it up. You could do that in your playground. Water-powered rocket, attach some seeds on it. Perfect.
That's really good. That's an easy one to do. There was a group, I can't remember what they were called. I think they were called Guerrilla Gardeners, and they used to subvertively throw seed bombs into disused areas in cities in order to make them bloom. I don't know if they're still going. Anyway, you could combine that.
We like that. Yes, I think as well, sometimes it's nice to use nature in a way of activism, and we like that.
I think so. Anyway, these are great. I'm not sure who sent these in, but whoever sent them in.
Yeah, thank you for this.
Clearly there's a genius. I enjoyed what you said about making mistakes as well, about this idea of being a perfectionist. And you're absolutely right. I think perfection is the enemy of done, getting things done. And I remembered, and I'm sure, I don't know if Thomas Edison, who invented the light bulb. I can't remember how many different filaments he tried to come up with, about like some ridiculous amount of filaments, and kind of kept on going until he found the one that actually worked.
Yeah, and there's lots of different examples of things that didn't work, but then we learned something, or we got a new invention out of that. And I think that is really exciting, is that actually we often see it as that we failed, and that somehow not worked. But actually, lots of amazing things that we take for granted every day have come from that failure. And I think that quite often we feel like we have to, like, particularly in certain subjects, there's a right answer, and we feel like there's only one way of getting to that answer. Whereas the job that I do, there are lots of different ways of kind of getting to that. And that's really nice. I like, I like trying lots of different things and ending up with a solution at the end of it.
Thomas Edison never invented a popcorn doorbell cannon.
No,
and I think he was a poorer man as a result.
Exactly. 11-year-old Lila, she had it sorted. She's like, do you know what we need to do? Fire popcorn everywhere. Exactly. And also, I think as well, quite often we think about these inventions being really complicated. And I don't mean to encourage you all to go home this weekend and build popcorn firing doorbells, but a lot of the things that we build, we take existing things and we smush them together to build these things. So for example, I often get a lot of comments that say, like, you should patent this. And as a patent holder for StairSteady, you can't patent these inventions because you're using things that already exist. And that's, in a way, a really nice thing, because you could go home and you could make it. So popcorn doorbell, actually, the main thing behind that is a leaf blower. So you might have one of those at home. You might use it to clear leaves off a lawn or whatever. But a leaf blower has been used in, so it's behind the door, and that's what fires out the popcorn. But we use leaf blowers a lot in our inventions. So often when we're firing seeds, the top secret one that we're releasing at Christmas, that uses a little leaf blower. So there's lots of things we have lying around the house that are really, really fun and easy ways to start experimenting and building with an adult.
So there you go. You're exactly right. Galileo, you may have heard of him. He invented some things. He invented he didn't invent the telescope, but the lenses had already been kind of used, and he thought, I know, what happens if I put two lenses together in a tube and look through it?
Yeah,
and lo and behold,
this is it. And I think quite often we think of STEM or STEAM as separate subjects, but lots of these things link to other things we might be interested in. You know, that they link to the world around us, to other subjects like English, our humanities, and things like that. So there's lots of different topics that link to this. And teachers, if you're listening, we do resources for all the videos. So new videos that come out also have resources with them. So if you want to use them in the classrooms, you can. But yeah.
Amazing. When I used to do Teen Tech, one of the inventions that kept coming up was lots of kids wanted to make a sort of giant swimming fish that would clean up plastic in oceans. Have you made that one yet?
Do you know what? We haven't, but I have seen similar ones. So we've done a few ocean inventions. And one of the trickiest things about doing things in the ocean is the fact that it's salt water. So salt water is corrosive. So we often get asked, like, what do you do with your inventions? And I usually say, well, it depends where we have to test it, because any invention we've ever tested in the sea does not last very long. So we haven't done one that cleans up plastic, although there is a really exciting like a bin. So they had some in Falmouth where they sit in the water and they collect the plastic.
Yes.
And they're really interesting. But no, most of the water ones we've done have been ways to travel on the water or to save you if you fall in the water. But yeah, if you have any water cleaning inventions, get them sent in. We'd love to see them.
Ruth. Get them to Ruth, and she'll, you know, who knows, you could become a billionaire as a result. She'll build your thing, and it'll take over the world. It's been so much fun. You're such an inspiration, and you're so brilliant, and your YouTube channel is so brilliant, and it's just a great idea what you do. It's great. So long may it continue. Do we have any more final questions for Ruth before we say cheerio?
It's coming to the end of the day. People are getting slow on the typing.
It's that 3 o'clock vibe. You can tell everyone's getting a little bit. Oh, and I need to go home. I think that's it. Thank you very much for taking the time to come on. It's been an absolute pleasure. Thank you very much indeed. I think that's it. Zara, is that it? Zara, give me a sign if that's it. I just want to, before we sign off, I just want to double check. Miss Elliott says, really appreciate you taking the time to speak with us. I would like to say a huge thank you to everybody who's taken the time to speak to us today. We've had a really interesting day, a jam-packed day, which has been fascinating. It's been fun. It's been interesting. Hopefully it's given you some ideas about what you might want to do after you leave school or during school. Maybe it's given you some ideas of careers or jobs, or maybe you've just found it interesting, which is absolutely fine. I want to say a huge thank you to all of our sponsors, actually, to Durham University, Teesside University, Research England, RTC North, all the people who've helped put today together. It's been really, really fun, and it's been such a pleasure to be able to be sort of stitching all these wonderful speakers together. Most of all, of course, I want to thank you, the people watching it. Thank you to all the teachers and to all the pupils, and to anybody else who's been watching. The children at Gillis Lane have had a great day. Thank you very much. Well, back at you. I've had a great day as well. It's been lovely to hear from you as well. So thank you very much. I think that's it. I shall say cheerio, and I'll see you next time. Thank you once again to everyone, and have a marvellous Christmas if we don't see you beforehand. £50 gift voucher for Amazon for somebody, don't forget.